Well, folks, yeah, I hope you all took your resolutions and you got on the train. You got to get at the station early to be able to get on the train, eh? Awful lot of people hanging. I'm all sideways in here. I was going to do some work, fixture work today, but that's not what we're going to do. It's a more important thing to talk about. There's been some talk about floating neutrals, floating grounds. What you gotta do, what is it? So I'm gonna try to give my interpretation. Hang on now. I gotta set myself down here. Ooh. Gotta point this in the right direction there. Am I all right here? Yeah, I am. Okay. No, I'm not. Hang on. I'm gonna move this. I'm gonna move that. And I'll bring us in a little bit closer there so you can get a gander at Gator. That's better, eh? Show my eyes in here. Hey, this is not for educational purposes. This is not complicated explanation. It's just a general explanation. There's been some people, grounds and neutrals, and what people do with them and their understanding of them is very mixed up, I'll tell you. I'll try to tell you, and I made a few notes because my old memory just kind of has a hard time putting everything together now. Well, first off, before we get into the notes, I'm just going to give you one instance where hydro at their poles, okay, have a transformer, and they have two it would be, you know, that triplex, or it's underground sometimes. Going to your house, there's 3 wires in that. There's usually a red, a black, and a bare wire, okay? And that's either buried, well, the buried in the ground. I think they have the white, okay, which is for them, for hydro, it's a neutral. But at the hydro end, they also have a ground, okay, which is in the transformer. Like if you look at the winding in a transformer, you got the red and the black from each side, and in the center you have a center tap, and from center tap to the end you got 110, center tap to that end you got 110, and from end to end you got 240. Well, 110, 120, okay, just 220. So I hope this is not complicating things. And their center tap is ground. What they do is they drop a bunch of, it's a coil of ground wire. When they dig their posts, they drop that. But sometimes they're on the rock, eh? And they'll carry that a few poles. So what they'll do is they'll ground it's the bare wire in between the poles. They'll ground that, and they'll carry it to the transformer, and they'll ground the center tap with that. Okay, that's specifically for lightning purposes. Has nothing to do with your house, your power, or your generator, or nothing. It's for their protecting their equipment. When they go from the pole to your house, they carry that in their bare wire to your meter base. I'm talking in general, like different states or different provinces have different regulations, but just in general, there's different instances. I know, like when we get to the service gets to the house from Ontario to Quebec, there's a few differences there on the mast, but we're not going to get into that. Okay, you come down in your meter base. Your meter base, your neutral just goes through it. Neutral, which is white, or the bare ground, which was at the top, but in your masting or in your service coming from in the ground, it's not grounded, it's isolated. It doesn't ground to the base, okay? There's another ground, which is a number 6 ground, okay? Is it 6? My memory fails me, or it could be number 3. I think it's 6, that goes from the meter base chassis to the internal ground. Now, okay, once you're in there, inside the house, your neutral is isolated, okay? And all your plugs, that's the big side. There's a small side on the plug and the big side. All the big sides on the plugs are all isolated right back. Isolated by meaning they're not grounded. They all go back to the panel, and they're on a terminal strip, which is isolated from the ground. And you have different panels have different ways of doing it. Most of them have a bonding screw. And your number 6 from your meter base comes down and goes on that terminal strip too, which is isolated, but you have a bonding screw to ground, okay? And then you'll have a jumper from that terminal to the ground terminal strip. The ground terminal strip is mounted on the chassis, and it's also grounded to your water pipes, to your pipe for those with city water, to the pipe previous to the meter, and or there's a jumper in between the meter to jump the meter. Those with a well, you have ground rods or grounding plates with a ground to the casing of the well. Okay. Not getting too complicated. Just a light. We're just skimming over the ways to do it, and then I'll get into the reason why it's done like that. Your ground that you have in your house, which is that little the mouth of the little smiley guy, that's just to ensure your safety. If something goes wrong and whatever you have, if you have a well, okay. It's something we should talk about, okay? Like, hang on. Just woo. Yeah, I'm getting excited here, eh, folks? It's because I didn't prepare. It's a charger, okay? It's nothing complicated. But then I'll show you the end of that, okay? It's just got a 2-prong plug. There's a big end and a small end. So it's to be connected one way. You can't switch it around because it won't fit, but it has no ground terminal, which is the mouth of the little smiley guy. So that means this is isolated equipment. It's all made out of plastic, so the manufacturer it passes ULC and CSA, that's the Canadian or the American electrical approval. It passes that, and they, by their determination, think that there's no danger of you getting electrocuted. If something goes wrong in there, because there's no metal part outside for you to touch, okay? And touch the sink, let's say the sink is a good ground, okay? So if this ever came live, and you happen to be touching the sink, okay, I'm going to a real good source there, one hand or another, so your path of power path would be through your heart. So it could be a dinger, eh? So they determined that this is not dangerous, so they let him go with just 2 prongs. But now, remember the heater I had the other day? Where is it? Where is it? Anyways, now I should show. Hang on, I'll be back. Yeah, I gotta show you. Cause if I don't show you, where is it? I'm coming. Okay. See? Now. Ooh, can't touch that. Hey, this here is made out of metal. Okay? Something goes wrong in here. And let's say just one of the elements breaks. And like it's from neutral to power. Okay, the element. So the one that goes to the power goes to ground. So this is not working anymore, so I put my hand on that. And it's still plugged in. And I put my hand on the sink. Ain't going to be a good story, eh? But I got a little smiley guy here, and the little mouth here is plugged into the ground. Well then, the power is on here. It's either gonna short out the breaker, okay, or if it's just if there's enough resistance here, it won't short off the breaker. If it's just a minimal short, just a small arc, okay, I still can get electrocuted here, but the ground is a path back, okay? It's either going to short it or it's going to bring it back to ground, okay? So you won't get electrocuted because the ground, the metal part is grounded with your little smiley face here, the mouth, and it's going to carry back. Okay, now we get into floating neutrals. Okay, we talk about a lot of floating neutrals on, especially on generators. Some generators have a floating neutral, and some don't have a floating neutral. Hey, there's a regulation, and the regulation states that you're supposed to only in your, never mind hydro can do whatever they want in your domain, okay, which is the house and your generator. You're only supposed to have one point of contact between the neutral and ground. So that point of contact can either be at your generator, or if you're feeding your panel, okay, or if you're feeding a circuit but it's still connected to the circuit in the panel, that ground has am I saying it right? That neutral has a path to ground through your electrical panel, through your circuitry, through your electrical panel. So in that instance, you want a ungrounded neutral, a floating neutral, ungrounded neutral in your generator, because your path to ground is in your house. But if you have a generator and you have a little that heater, this heater here, well, you want a path to ground. Not only that, on your generator, because this is hooked up to the generator, right? And that's the only connection you have. Well, that generator sitting on your tailgate is not grounded. And you want this, if you want it to short out the breaker, that neutral has to be hooked up in the generator, has to be grounded, and that generator has to have an earth, which is ground. Okay, so that generator on the tailgate is good, but don't expect too much protection from indifference. But if you got a just like this, the newer tools, they're all plastic, so then you don't have to worry about that so much. But if you got an old drill or an old skill saw plugged onto the generator, well, then you get into more compromising, and you don't have to run a 10-foot ground rod, but you can have just a little ground rod. Well, the law states that you're supposed to ground it, okay? Regulations. But you can do whatever you want to do. There's a reason why, I know I'm going all over the place with this, and I hope you're following. There's a reason why hydro, and all this has to be inspected, by the way. Even those that live in the bush there with their home done electrical, well, it has to be inspected, and there's regulations to follow, and size of wire and stuff like that. So, and there's a lot of people that do their own, and then 2-3 years down the line, I won't mention no name at this time, but there is one particular place where I told a guy, you don't want to put lights and plugs while you're at it. Well, it's been 2-3 years now since I told that to him. He was finishing his upstairs, Now he's in his basement. He's talking about doing some electrical upstairs. I can't wait to see what he's going to do. It's all closed, okay? Ceiling closed, walls are closed. How hard is it to do electrical now? And Hydro wants to see, they have to inspect, So you're into a whole new ball game, So when you're building something, build it and get it inspected. And if you decide to get hooked up to the hydro, then you'll have something that you won't have to redo again. Okay, where was I? Okay, and now we're gonna get to my notes, okay, that I wrote before is this getting long? Anyways, okay. A neutral device, hang on, I can't read too good, I don't even have my glass. Neutral device is a device operated, returned to power and ground. I can't even, okay. A neutral is a device that gives the power a return to ground. It gives the power source, okay, a bias to ground. See power and neutral, that's a source of power to a device. A ground is just protection. So if you think of it this way, that's what I was trying to write, but when I wrote it down, I was thinking of something, but I didn't have the story. Okay, a ground is a device not connected to power. It only serves a purpose. That's in your house. It only serves a purpose in the case of a device failure. It protects you. Okay, this is what the ground does. Okay. Oh, while I'm thinking about it, Steve Robb mentioned something about the houses in the '60s. Just because you don't see on the plugs, you don't see the little smiley face. Some of these outlets had a ground to the box, but didn't have the little tail hooking up to the plug. So all you do is you take that plug off, take it off altogether, and you can put a newer plug on. You go back in the bottom of the box, and there's a screw there, a ground screw, and just put a tail, and then you'll have a ground for your plugs. But prior to see, this was an old tar and paper Romex. That was in my younger days. Prior to that, I was on the map. I was born, but I wasn't doing electrical. Hang on, I can't see you guys. Yeah, there was wire, and all they had was the 2 wires. Okay, well, it still is. Like us, an electrician always talks about 214. That's the wire you buy. If you look on the jacket, it's written 314, but there's only 2 wires that you really use in there. We call it 214, but it's 3 wires and there's 14. I think written on the jacket, it's 14-3, because it's number 14 wire, and there's 3 conductors in there. But that's not really true, because your ground is one size smaller than your conductors. Anyway, that's something else. Okay. Okay, the ground wire in your panel going to your ground rods and your grounding plates in the ground gives a reference in your house, okay? All your grounds in your house, it gives them a reference to earth, which is ground, okay? And remember this, it's not part of your power circuit. It's only for your protection. Okay. Okay, this is a little bit interesting. I don't know if I'm going to lose these guys in this. Okay, neutral and ground has the same potential, okay? Because neutral is grounded, but they don't have the same purpose. Ground is for your protection. Neutral is for an electrical application. And I don't want to get into like the windings and the balancing of the phases. Like when you get into commercial applications where you have 3-phase and you have a lot of different circuits, well, you don't want to end up with let's say if you have a 200 amp, I'm just going to tell you an instance where you have a 200 amp service. And out of those, that's the capacity. Every line coming in has the capacity of 200 amps. There's A, B, and on commercial applications, there's a C phase. They get that through a Y delta or a delta connection, but that's something else. And they're grounded too, and there's a center tap, which gives them the neutral, but that's something else. I'm just going to say, what did I want to say anyways? I get lost here. See what happens, eh? Anyways, you when you set up your panel, you always try to get more or less of a balanced load. By hydro regulations, you're supposed to have 0 unbalanced on your neutral, okay? If your panel would be perfectly balanced, you would have zero return on your neutral, because all your phases would have the same load. On a residential, it's almost impossible, but on a commercial, we get it pretty close, and I've seen sometimes bang on. It's easy when you have everything's 220, eh? When everything's 220, and when you get 3-phase, well, you just alternate, eh? And you always have the same, let's say on a lighting load, you always have the same load on each circuit, so then it gets easier. Hang on. Hang on there. Oh yeah, it's your hydro ground is, I said there, the lightning, and lightning does strike in houses too. That's on my notes here. So I was young, I think a 2nd year apprentice, and we were working, it was a flat land, and I think the panel in the house wasn't finished yet, so we didn't have a ground on the panel. But we were doing the wiring and we are tying the. I'm thinking that's something I'll have to let you know. We're tying all the the grounds, and we're putting on the Mars on the connectors. And there was another guy. He's an older guy. He was about maybe 20 years older than me. And lightning fell on the wires. In that house. It was a brand new house. Well, that guy flew out of that. He was in front of the box, so he's standing. He's tall, maybe 6'6". He went flying about 10 feet, and he's on the ground. He was knocked out for about 10 minutes. We found it funny at that time. And well, where was I here? I'm kind of shifting all over the place here. Okay. Yeah, there's an article, in the code about neutrals, and it's Article 250. It deals with the neutral and the grounding a conductor carrying grounded conductors, for neutrals, So those of you that care a little bit, well, you check that. It's Article 250. It's your grounds are also you've seen these plugs in the house. They're ground fault plugs. Well, your ground serves as a bias to neutral, true power, and it's the electronics. Will make it trip. Okay, the big difference between neutral and ground is that the neutral is current carrying, but ideally it's zero. Current carrying, but ideally zero, and the ground is only safety for you for shorts, and it makes your it gives a bias to neutral for your ground faults. I hope I'm saying all this, but most of you probably won't have followed me through this, and those that are knowledgeable, there's probably some in there that are saying, what is he talking about anyways? Okay, the thing to remember through all of what I said, neutrals are grounded one time. The ground in your house is for your safety. That's a pat to earth, This is for your safety, and it will short out the breaker if something goes wrong, That's the purpose of the ground in your house, the main purpose, There's some instances, where hydro doesn't even have a good ground. I've seen that too. I shouldn't tell you this. But anyways, they don't really have a good ground because their poles are set up on the rocky I should finish what I'm saying. So they rely on the people's grounds too, to give their ground a better earth connection. There's something I'll see, but I won't get into that. Ground at one place is not necessarily ground at the other place. So if you have, let's say if I have at my cottage, I got a ground at the cottage. I have 2 rods, and I buried, because I'm on rock there, and we could talk for hours about ground, and I took a megger, and I checked it, and I didn't really like the readings that I got, so I went in, I ran a number 6 into a very humid area, and then along the well, and then I buried a ground plate, which is specifically done for that, so that betters my ground. Hydro can ask for, in specific locations, they can ask for readings on ground. I was going to say something, but I forgot what it was, so it's probably not true in that case, Anyways, so what was it? Had to do with more or less a question about what people had asked about neutrals, floating grounds and floating neutrals. Floating neutral in a generator would serve the purpose of isolating the neutral from the ground, because if it feeds something that's already neutral grounded, then you can't supply another neutral ground. But if you are in need of a ground, then so a generator has to, and some instances where generators do have a connection to neutral, to ground, and then you run these electronic furnaces and gas furnaces and oil furnaces. The igniter won't work, it'll trip. If it sees another ground, like on the house power, it won't accept the power coming from the generator. So that's an instance where you see, especially in the electronic equipment, they're kind of fussy about that. All the electronic components, about what they're seeing, and so be weary of, it's not the end of the world, but just as long as you know that if you hook up your generator and you're blowing a GFI or whatever you're hooking up trips, well, that's because your generator, you can test your generator to see if it's a floating neutral or if it has a grounding neutral. Just take your ohm meter and go from power, from neutral to ground. It's either connected or it's not connected. If it's not connected and you need it get connected, if you're knowledgeable, you can buy little boxes that do it for you. But those of you that are knowledgeable, you can get in the panel circuitry there. If you want it isolated, you isolate it. Or, better still, I'll show you some. But, hang on. Okay, here. I'll just take this here. I have a lot of them down there. You just take a plug like this, okay, plug cap, and all you do is, see, your generator always has two plugs, eh? Well, you take one of these and you go to the wide prong here and you put a jumper to ground, okay? So this here, you just plug that in the bottom plug and automatically this will ground your neutral on the upper plug that is the spare plug. If you want it disconnected, well, you can install on the, you have to look at the circuitry inside your generator, and you can isolate, you disconnect the ground from the neutral wherever they have it. As long as it's not in the windings of the generator, then you'd be, there's probably an electronic, oh yeah, if you had, a big word here, if you had an auto transformer, it's an auto transformer is a way. If I have power here, and I'll give you, I have power here, I'll give power there, but they're completely isolated. There's no connection. It's one winding and another winding, and there's no connections between the winding. So if you had an auto transformer, you can do what you want to do. Or this is starting to get advanced a little bit for what I'm trying to explain. But anyways, I just hope this all makes sense, folks. It's Gator's floating neutral, floating ground explanation. I don't know if I did a good job on this. I will tell. Anyway, if you want to poke around on electricity, my way of explaining is not necessarily a good way because I'm not a teacher, right? So don't be poking. The best way is phone an electrician. And some of these electricians, they're just basic electricians, and they don't know I'm not talking, well, if the hat fits, put it on. That's what I'm talking about. There's some electricians that more advanced, okay, they've learned more. There's some electricians that they learn on the pile, eh? And their interpretation of things is not the same as, not their education is not the same. I don't belittle these people because everybody has to earn a living somehow. I'm just saying that education is not all the same, so be weary. Nah, you should trust an electrician with papers, okay? Because I'd say 99.9% of electricians they won't steer you. Some of them know things, and it's just because they've did them so long, they don't know the reason why. You got time, you guys? Just a little story when I was young, eh? And I was just a first-year apprentice working with an older guy. He's just, well, he's probably 65, 68, I don't know. I used to think 68 was old, but now that I'm older than that, I don't think it's that old anymore. But anyways, this guy, he was grumpy, eh? And I asked him, because I was curious, eh? Like a fan and these little fans in the washrooms there, eh? All they do is they make noise and they don't like circulate the air. Well, we were wiring that, eh? And I asked him, I says, how can we reverse the rotation of that fan? If I said, could it be that it's turning the wrong way? He said, he says, never mind asking those questions and just hook it up, that's it. And you know why he said it that way? It's because he didn't know the answer. When I went to school, I found out the answer because we studied motors, eh? And these small motors, they're the cheapest motors that you can get. They call them shaded pole motors. And you can't reverse rotation. The only way you could reverse rotation, okay, is if you took the motor and you took it apart and you took the armature with the shaft and you turned the winding, like turned it 180 degrees, put the armature back in, then it would reverse. The shaded, like it's the winding is around the, what did they call that? It's all the metal that's all stacked together. I forget. Jeez, I'm bad now. But anyways, this is what makes the interaction between the magnetism in this and the rotor is what makes this run. And there's a pole on that metal. There's a pole at one place that draws, eh? It draws and it pushes like north to south, okay? So it makes the rotor turn. But if you turn that around, then it'll make it turn the other way. But anyways, you don't have to know that. Unless you have a washroom fan in your house that's turning the wrong way, then Gator told you how to fix it. Don't bother. Throw it in the garbage. It's no good anyways. Buy something that's decent with a real motor on it. Anyways, and most, you got time, you guys? Yeah, I'll tell you something. Like a lot of these motors, like these drill motors, now they're talking about the brushless motors, eh? But the motors, well, not these. What am I talking about? The ones, okay? The ones with the cords on them, okay? Remember those? The drills with the cords? That's most young guys haven't seen that, eh? But they used to have a cord on them. Most of them motors were DC motors, but they had the hooked up power. They were isolated in the way that they could take the AC, the 120 volts, but they were a DC motor, DC brush motor. Anyways, that's neither here nor there. One day I'm going to take out my Rosenberg book on motors. They're going to go through it. This is going to be, when I do that, it's going to be probably a 2-day thing. No, I won't do that. But it's just, I used to go to school. That's in my younger days, eh? I had bought this book, and it's anybody that works in motors and things like that. That's the Rosenberg book on motors, but it has nothing to do with today's topic. Well, it does, eh? Because there's a whole. This book opens in two. One part's motors, and the other part's transformers. The transformer part has something to do with what we talked today, the grounds and the neutrals, floating neutrals. They talk about delta, open delta transformers, which is a whole different ball of wax when they get into that, but we're not taking an electrical course. This is why I didn't want to really talk about electrical here, because we can get into God knows what. Okay, folks. I salute you all. Comments are welcome if you want to expand on this. And I enjoyed myself. I hope you did. Okay. Hey, don't forget, all the New Year's resolution there. We ought to have some in there. Okay, bye-bye for now.